these are fractions. These are fractions. These are fractions. Could you see these fractions? Here, this is read as, this can be expressed as, here 4, here 5. This can be mentioned as 4 over 5, 4 over 5, 4 over 5, 4 over 5, or 4 and 5, 4 and 5. And yeah, so 4 over 5, 4 over 4 and 5. Then this one also can be read as 4 over 6 or 4 upon 6, 4 over 7 or 4 upon 7, 6 over 2 or 6 upon 12. That's the way of mentioning these fractions. Okay, so what is this one? This one, in general, we say that half. This is half or 1 over 2. So this is 1/4. This is 1/4. This can be mentioned as 1 over 4. So how about this one? This one can be mentioned as, this one can be mentioned as 3/4, 3 over 4, 3 or 4 and 4. But anyway, you will be able to understand the ways of mentioning these fractions in the future properly. So then here you how to understand that proper fractions. When it comes to this idea of proper fractions, before this, you should know that then this is 3, this is 5. The number that you could see below this line, the number that you could see below this line, we name as denominator. This is denominator. This is called as numerator. Anyway, this is denominator. This number is denominator above, below the line. Number that you could see here is denominator. Above this line, the number that you could see in this fraction is numerator, right? We generally do not say that denominator value. We say that denominator. This is denominator, this is numerator. Okay, so what is the denominator here? This is 6 over 7. The denominator is 7. Denominator is 7. Numerator is 6. Then here 11 over 12. What is numerator? The numerator is 11. The denominator is 12. Okay. So now you understood that the way of identifying, the way of writing denominator and the numerator of a fraction. So 5 over 7, what is denominator? Denominator is 7, the numerator is 5. Okay, now I will be teaching you proper fractions. What are proper fractions really? So 6 over 7, 5 over 12, 7 over 6, 5 over 12. You could see these two fractions. Then here 6 over 7, here 7 over 6. So denominator here is 7. 6 over 7, when it comes to this fraction, denominator is 7 here, numerator is 6 here. So if the denominator is greater than, 7 is greater than 6. Now here, if the denominator, when it comes to a given fraction, if the denominator is greater than the numerator, then this fraction is named in maths as a proper fraction. this value, I mean 7 should be, then you could see 7 is greater than 6. I mean, when you write generally, you know that 1, 2, 3, 4, 5, 6, 6, 7. 7 is greater than 6. Then if the denominator is greater than numerator, then that type of fractions, I mean, when it comes to this 6 over 7, here is a proper fraction. So just to think of this 6, then 7 over 6 cannot be considered as a proper fraction. Then I will be teaching you the type of this fraction right now. After a few minutes, I will be teaching you the type of this fraction. So therefore, you could see 7 is greater than 6. Therefore, 7 over 6 over 7 is greater than 6. Therefore, 6 over 7 is a proper fraction. Then just you could see here this 5 over 12 as well. 5 over 12 as well. Denominator here, denominator is greater than numerator. Therefore, this fraction also, 5 over 12 also can be identified as a proper fraction. 5 over 12 also a proper fraction. So think of this one on 1 over 2. How about this one? Can you see this? This is called, in general we could say this one as half. Anyway, this 1 over 2 can we take as a proper fraction? Just think of the previously mentioned taught rule or taught segment. Then here also you could see denominator is greater than numerator, which means then 2 is greater than 1. Therefore, this fraction also can be considered as a proper fraction. How about 3 over 4? So here denominator value, which is 4, is greater than 3. Therefore, this one also can be understood as a proper fraction. Now I do think that you can identify, you can understand that the meaning of proper fractions. Okay, if the denominator is greater than numerator of a fraction, of a given fraction, then that fraction is named as a proper fraction. So next point is, just think of this one, 4 over 7, 11 over 2, and 3 over 8. Can you choose proper fractions here? Then this can be taken as a proper fraction. This one also can be taken as proper fraction. The reason is, denominator value is greater than the denominator is greater than the numerator. I mean, here 7 is greater than 4, 8 is greater than 4. Therefore, this fraction and this fraction can be considered as proper fractions, but this cannot be taken as a proper fraction. Then this type of fraction is this one. Wait, I will be teaching you. So next one, unit fractions. Unit fractions. What are unit fractions really? Unit fractions. Already you know that denominator and numerator. When it comes to these fractions, you would see then here 1 over 7, 1 over 9, 1 over 8, 1 over 100. So when it comes to these fractions, you would see then numerator, every time numerator is 1. Here 1, here 1, here 1, here 1. So then what are unit fractions? The fractions that you would see numerator is 1. Every time the numerator should be one of unit fractions. Okay, so these are unit fractions. Then are we able to consider this one as a unit fraction? Are we able to take this one as a unit fraction? Then really you know that 1 over 1 is 1. So this is not fraction. So we can't take this one as a unit fraction. So anyway, these fractions, these fractions we identify as unit fractions. Numerator is 1 here. So in these fractions, so therefore these fractions we name as unit fractions. Now you know that proper fractions, unit fractions. Next one is, next type of fraction you should know equivalent fractions, equivalent fractions, equivalent fractions, equivalent fractions, equivalent fractions. What are equivalent fractions? Equivalent fractions. Equivalent fractions. Equivalent fractions. Equivalent fractions, equivalent fractions, equivalent means equal fractions. Then I will teach you this one. Then I'm going to divide this, here is a value, what I am doing here, 1, 2, 3, 4. Then, this means really, then whole part, what I have done here, then this whole part, the whole segments, the same segment is divided into two equal parts, which is, that 1 over 2. This can be identified as, when you were in lower grades also, then when you were in last year also, I do think that you've been taught this type of one, then you could mark this one as 1 over 2. Okay, this is 1 over 2. Then this whole segment has divided into two equal parts, and you colored one part. This can be mentioned as 1 over 2. Then the same one has divided into 2 here. Then this can be expressed as 2 over 4. Right? 2 over 4. The same value has divided here then into two equal parts. Then this can be mentioned as 2 over 4. Then this can be mentioned as 1 over 2. So then these two fractions we name as equivalent fractions, which means then same value you could see here, then 2 over 4 equals 1 over 2. So you could see basic thing is, the thing that you need to realize here is same one, same figure, same diagram has divided into two equal parts. The same diagram has divided into two equal parts, and it has taken one part. The most important thing is then same region you could see, then from here to here distance equal, same region, same part we considered, we taken. This is the most decisive thing that you need to consider here. So same thing we've taken, same region, same area we've taken, right? Same region, same part we've taken. So which means then 2 over 4 equals to 1 over 2. So this fraction and this fraction can be identified as equivalent fractions. So I'll be explaining this one to you more. Then how can we write an equivalent fraction to this half? Then we can write an equivalent fraction. Then the way of writing equivalent fractions, same value, same digit can be applied, can be written in terms of writing equivalent fractions, which means, this side denominator multiplied by 2, numerator as well, you could multiply using 2. Then here 1 into 2 is 2, 2 times 2 is 4. Right now you know that half equals 2 over 4. So half and 2 over 4 are equivalent fractions, which means half equals to 2 over 4, which means another way of mentioning, another way of representing half is 2 over 4. The same value, same fraction, right? Same fraction we could express using this method. There are many ways of then how many fractions, how many equivalent fractions are you able to get for half? Unlimited equivalent fractions can be taken. Don't forget, equivalent fractions are taken. You could take equivalent fractions, both denominator and numerator multiplying using an equal value. So then here I've taken the digit 2 to multiply both sides to get this equivalent fraction here. So here just think of then another equivalent fraction. Let's take this half. Then both sides, previously I multiplied both denominator and numerator using 2. Here right now I could multiply both sides using 3 here. Then this side denominator can be multiplied by 3, numerator as well. I put this the digit 3 into these boxes so that you can see here. Really, when you write, no need of writing these boxes. Then 1 times 3 is 3, then 2 times 3 is 6. The other equivalent fraction to this half is 3 over 6. Another equivalent fraction also we could write for this to this half. Then consecutively we multiplied both denominator and numerator using 3 and 2 and 3. I could take 4 as well. This side by 4, denominator can be multiplied using 4, numerator as well. So 1 into 4 is 4, 2 times 4 is 8, which means half equals to 4 over 8. Okay, so the way of writing equivalent fractions to given fractions, both sides, both denominator and numerator can be multiplied using the same digit. That's the one way of writing equivalent fractions to a given fraction. The other way, what's the other way? Number 2 is, you could divide both sides using the same value. How can you find an equivalent fraction to 6 over 8? An equivalent fraction to 6 over 8. You could take an equivalent fraction to 6 over 8. Both sides you could divide using 2. Denominator as well. How did I divide? When I observe this fraction 6 over 8, I could see that 2 is a multiple of 6 is a multiple of 2, 8 also a multiple of 2, which means then 2 times 3 is 6, 2 times 4 also 8. Okay, so therefore what did I do here? I divide both sides by 2. So 6 upon 2 is 3, then 8 upon 2 is 4. The answer is 3/4. Okay, then an equivalent fraction to 6 over 8 is 3 over 4. So equivalent fractions can be taken dividing both denominator and numerator using using a digit. Same digit uses to divide both denominator and numerator to get an equivalent fraction. So there are 2 ways of getting equivalent fractions. Number 1 is, you could multiply you could use the same digit to multiply both denominator and numerator in order to get an equivalent fraction. You could multiply both sides using the same digit. Number 2 is, the second method is, you could divide you could use a digit to divide both sides, both denominator and numerator, to get an equivalent fraction. So you could multiply, you could divide to get equivalent fractions, but don't forget it should be used an equal digit is used to divide and multiply. Is that clear? I do think that you understood this one. So the next point is, really don't forget then here what I'm doing here, I'm teaching you the related segment of fractions of grade 6 students, right? So now we could write, we could compare, right? We could compare fractions, given fractions, we could compare, right? Comparison of fractions, really. So tell me then 1 over 5 and 2 over 5, what's the greater fraction here? What's the greater fraction here? 1 over 5, 2 over 5, what's the greater fraction here? The same value, same thing what I'm doing here, I'm going to divide into 5 equal parts, then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. The same thing is done here as well. So, 1, 2, 3, 4, 5. Here, one segment is shaded here, which is 1 over 5. Here, 2 segments are shaded. So, 2 over 5. Now you could see, when you observe this taken diagrams here, the greater fraction is 2 over 5. So 2 over 5, 1 over 5 and 2 over 5. The greater fraction here is, this one. So greater one is 2 over 5. So when you see, you could see then here, just every time no need of drawing these types of diagrams to get the answer here. But why did I do here? Why did I draw these 2 diagrams so as to convince you, so as to teach you properly this segment really. So here 5, then you could see denominator equal, here 5, denominator equal 5. Now you could consider, without drawing these types of diagrams, then 2 and 1, then the greater digit here when it comes to numerator is 2 here. Therefore, we could take 2 over 5 as the greater fraction than 1 over 5. So 4 over 6, 5 over 6, 4 over 6, here I will write that 3 over 6. What is the greater, 4 over 6 and here 4 over 6 and 3 over 6 here. 4 over 6, 3 over 6. Then denominator values you could see equal. So then 4 is greater than 3. Therefore, the greater fraction is 4 over 6. So write down, you could write these given fractions in ascending order. You know, ascending order means then smaller one to greater one. Ascending order. Ascending order. How can you write these fractions in ascending order? 1 over 5, 1 over 5, 3 over 5 and 2 over 5. I mean the least fraction. Least fraction. What's the least fraction? You need to write these given fractions in ascending order. Ascending order. Ascending order. How can you write these fractions in ascending order? The least fraction is 1 over 5. The other one is all these values are equal, denominator equal. So the other one is 2 over 5. The highest one is greatest fraction is 3 over 5. So we've written these fractions in ascending order. Don't forget, again I will be mentioning you this one. This segment relates with grade 6 students, right? More knowledge of fractions will be taught when you go for higher grades. Okay, next question is, you need to write this one as well in ascending order. 11 over 12, 4 over 6, 6 over 12. Here, you can see, then here 12, here 12, denominator here 12, here 12, here 6. Then, so as to get the answers properly, you need to get an equal value for denominator here. So, to write these fractions in ascending order. So, therefore, what we are doing here, we multiply, we are going to get here instead of the 6, 12. So we multiply both sides by 2 using, it takes 2 to multiply both sides, both denominator and numerator. Reason, when you multiply both denominator and numerator using 2, you can get 12 here, then here 12, here 12. That's the reason of multiplying both denominator and numerator using 2. So here 6 over 12. These two fractions are not changed. Right now you could see, then really this knowledge you gain in the previous segment of equivalent fractions, and you would multiply both sides using 2. Then 11 over 12 and also 4 times to 12, then 6 times, 4 times to 8, 6 times to 12, 6 over 12. Right now here 12, here 12, here 12, denominator equal. So the least value, least fraction we would take here, then 11, 8, 6. So 6 over 12 is the least one. After that 8 over 12. After that 11 over 12. Really here 8 over 12 means this is not given in the question. Then really we've taken this one. Therefore the final answer can be kept as 6 over 12 and 6 over 12. After that using 4 over 6, we've taken this 8 over 12. So, here we can write 4 over 6. After that, we can write 11 over 12 here. 11 over 12 here. So, this is the answer. Okay, so next point is, I'm going to teach you addition of fractions and subtraction of fractions as well. Um, how to add this type of fraction? 1 over 5 plus 1 over 5. So 1 over 5 plus 1 over 5 means you can add this 5 and this 5 we do not add, as then 5 plus 5 is 10. Then if you are doing so, then that's this way is wrong really. So we don't add denominators, right? We don't add denominators. We write denominator. Then 1 and 1 we can add as 2. Then 2 over 5 is the answer. So first question. The second question is 4 over 5 minus 1 over 5. This one also can be simplified as 4 minus 1 is 3. Then the answer is 3 over 5. So how can you do this type of question? So 7 over 30 plus 7 over 30 plus 2 over 3. Here you could observe the question first. Here 30, here 3. So you need to convert this. You can't simplify these fractions. You can't add these fractions. The reason here 30, here 3. Then in order to add these fractions, you need to get equal denominator. Here 30, here 3. Then first of all, what we need to do, we need to equal denominator. So here 30, here 3. How can we get 30 here? So as to get 30 here, we have to multiply. We need to multiply the digit 3 by 10. So denominator multiplied by 10, numerator as well multiplied using 10. The reason why do we do this? In order to get the equal denominator here. Here 30, then here what we are going to do, take 30 here. 30 here. Then 7 over 30 plus 2 times 10 is 20. 20 over 30. Right now here 30, here 30. You could add these two values, and 10 plus 7 plus 20 is 27. 27 over 30 is the answer. You can't simplify this fraction more. Okay, so I'll be teaching you this question as well. And then after that, you will be able to do all the questions that you would see in your test paper, right? In your textbook, really. 1 over 10 plus 2 over 5 plus 2 over 20. How can you simplify these fractions? How can you add these fractions? Here you could see here 10, here 5, here 20. Then you can convert this 5 into 20. This 10 into 20. I mean, you could convert. You can convert this 5. We could write this 5 as 20. Why do we convert? Why do we get here 20? So as to simplify. Every time when you simplify, when you add fractions, when you subtract fractions, you need to get equal denominator. That's the reason of multiplying this 5 by 4. 5 times 4 is 20. Then 10 times 2 is 20. So here 20. Therefore, this denominator multiplied by 2. Then 10 times 2 20. Numerator as well. You must multiply using 20. 2. Then 10 times 2 20. Then how can you simplify here? You could get here 20. So as to get 20 here, denominator multiplied by 4. 5 times 4 20. That's the reason of writing here 4. Both numerator as well. Then 2 over 20. Right now, 1 times 2 is 2. Then 10 times 2 20. Then 2 times 4 8. 5 times 4 20. Then 2 over 20. Now you could add these values. Then 2 plus 10, here 20, here 20, here 20, right? So 2 plus 8, 10, 10 plus 2, 12. 12 over 20 is the answer. Okay, so this is the answer of this addition of these fractions. So just try to do the questions that you would see in your test paper, in your textbook especially. Then if you are unable to do a question, just mention it, issue as a comment in the comment section. Then I will be helping you to get the answer for that questions, for that issues. I'll be resolving your issues if you are mentioning your issue in the comment section. So I'll be doing more videos in terms of your benefit in the future as well. Okay, thanks a lot.